morning, Shem Stars. Welcome to the class of chemistry. Today we will begin with the topic
Marbles. Round, colorful, beautiful marbles. When marbles are lying in piles or stacks, we observe certain patterns or packing arrangements. That's what our today's topic is. Close packed structures in one dimension and two dimensions. Well, in solids, these particles are tightly packed, leaving the minimum vacant space. Let us consider these particles as identical hard spheres and build up the 3D structure in 3 steps. In today's class, we'll cover up one dimension and two-dimensional structures. In one dimension close packing arrangement, each sphere is in contact with two of its neighbors. That is clarified further with the slide. In this one-dimensional close-packed arrangement, coordination number is 2. What is this coordination number? Number of nearest neighbors of a particle. Right. If we think of same arrangement in 2 dimensions, that can be possible in 2 ways. One, square close packing arrangement. Another one is hexagonal close packing arrangement. First one, square close packing arrangement, where second row can be placed in contact with the first one in such that spheres of second row are exactly above those of first row. Spheres of two rows are aligned horizontally as well as vertically. If we call first row as A-type row, then the second row being exactly the same as the first one is also of A-type. So we can call this arrangement AAA type, right? In this arrangement, further we can say where each sphere is in contact with 4 of its neighbors, so we can say two-dimensional coordination number would be 4. Also, if centers of these 4 immediate neighboring spheres are joined, a square is formed. Hence, this packing is called square closed packing in 2 dimensions. So question can be asked, why do we call this packing as square closed packing arrangement in 2 dimensions? So we can easily answer. Alright. Right. Second method where we can place second row to the first row. That is, second row placed above the first one in a staggered manner. That means spheres of the second row fit in the depressions of the first row. If arrangement of spheres in first row is called A-type, the one in the second row is different, that may be of B-type. When third row is placed adjacent to the second in staggered manner, again just like fitting in depression of the first one, the third row is placed adjacent to the second in staggered manner. Its spheres are aligned with those of the first layer. Hence, this layer is also of A-type. The spheres of similarly placed fourth row will be aligned with those of second row, that's B-type. Hence, this arrangement is of AB-AB type. In this arrangement, there is less free space, and that's why this packing is more efficient than the square close packing. So here question can be asked, why hexagonal close packing in 2D is more efficient than square close packing arrangement in 2 dimensions? So reason is clear, we can easily answer. In this arrangement, each sphere is in contact with 6 of its neighbors and the 2-dimensional coordination number would be 6. When center of these 6 spheres are at corners of a regular hexagon, that's why we call this packing as 2-dimensional hexagonal close packing. It's clarified further with the slide. That is, there are some voids, empty spaces. These are of triangular shape. These triangular voids are of 2 different types. In one row, the apex of triangles are pointing upwards and in the next layer downwards. So to wrap up this class, we can discuss few questions like what do you mean by coordination number, why HCP arrangement in 2D that's more efficient than square close packing arrangement in 2 dimensions, that we have already discussed in the class. In the end of this lecture we can easily answer, right? We'll discuss more questions.
Thank you, Shemstars. That's all for today. You can drop your queries on Google Classroom. Take care.